So for today's lesson, we're going to prove that the area of a triangle is half times base times height. So let's first begin with our triangle, and we'll assume that the length of this side is A, and the length of this side is B. And we're going to assume the area of the triangle is K. So we don't really know what the area of a triangle is, but we are aware of how to find the area of a rectangle. So we're going to extend or draw a line from that's the length of A, and then draw another line that's the length of B to create this rectangle. And as you can see, we know that the area of rectangle is base times height from a previous video. So that means the area of this complete rectangle that we've drawn is going to be A times B. Now if you notice that we actually, to create this rectangle, we created two congruent right triangles. So the area of the triangle with the dotted purple line also has an area of K. So with that in mind, we know that the total area of this rectangle is K plus K, and we already know that the area of the rectangle is also A times B. So K plus K is equal to A times B, which can also be written as 2K is equal to A times B. And we can divide the equation by 2. We get that K is equal to A times B divided by 2, which is what represents the area of our triangle. And this can also be written as, because if you remember, A is representing the base of our triangle, and B is representing the height. So, and we came to a conclusion that K is equal to half A times B, which can be written as a general formula, half base times height. So how do we know this will work for all triangles? Well, let's say that, okay, the area of a right angle triangle is half base times height. And now I'm going to draw myself an acute triangle, which means all three angles are formed by an acute angle. And so we're going to try to call this triangle ABC. And we're going to draw a line from A to point straight perpendicularly down to point D. And by doing so, we ended up with two right angle triangles. So we know how to find the area of two right angle triangles. And if you see here, we have the right angle triangle ABD and the right angle triangle ACD. So if we find the area of these two right angle triangles and add them up, we'll get the total area of triangle ABC. So the area of triangle ABD is half times BD times AD. And the area of triangle ACD is half times DC times AD. And what we're going to do is add them up, because that will give us the total area of triangle ABC. And that gives us the area of triangle ABC is equal to half times BD times AD. The area of triangle ABC is equal to half times BD times AD plus half times DC times AD, which is equal to, if you notice, we can factor out the AD and we'll end up and the half. So by factoring out the half and AD, we end up with half times AD times BD plus DC. And if you look at the diagram, we see that BD is this line and DC is this line. So those together combined will form the line BC. So we can replace BD plus DC with BC. So we end up with half times AD times BC. Now, AD is actually the height of ABC, of the triangle ABC, and BC is the base of triangle ABC. So that shows that the area of triangle ABC is also half times its height and base, which is the same thing we've retrieved here. But what about if we have an obtuse triangle, which is a triangle with one obtuse angle? Well, let's draw ourselves an obtuse triangle, and again label it ABC. And what I'm going to do is draw a line straight down from A and call that point D, and I'm going to line it up with BC. Now if you look here, we have two right angle triangles. Firstly, we have triangle ABD, and which we created from with the dotted red line and dotted orange line. And we also have the larger right angle triangle, which is ACD. Now, we know that the area of right angle triangle is half base times height. So in this situation, we have to find the area of triangle ABC, we have to subtract the area of triangle ACD from triangle ABD. So the area of triangle ABD is going to be half BD times AD, and the area of triangle ACD is going to be half BC times AD. And so the area of triangle ABC is going to be the area of triangle ACD minus the area of triangle ABD, which gives us half times CD times AD minus half times DB times AD. And if we factor out the half and the AD, then we end up with the area of triangle ABC to be half times AD times CD minus BD. Now if you notice, line BD is this one, and line CD is this one. So when you subtract them, you're only left with half times AD times BC. And even in this situation, AD represents the height of our triangle ABC, and BC represents the base. So again, we can write the triangle ABC has an area. Its area can be represented as half times its height times the base, which again is the same thing that we have here. So this shows that regardless of whether you have a right angle triangle, an obtuse triangle, or an acute triangle, the area will always be half times its base times its height.